So in this session, we're gonna start with chapter 3. It's about basic objects. This week, uh, it's all about basic objects and variables. Um, these might sound like small details, but they are the foundation of everything we do. So let's start with the objects. So an object is basically a thing in your program that has both data and behavior. So uh, in Java, the object has components that hold data, like uh, uh, when you like variables. It could be uh, in data related to health or something like that, and methods that do things uh, like actions you call. uh, so quick example. um, so let's say strings is equal to I. I system dot out dot println s dot length. Let's create another system dot out dot println s dot to upperCase. So what's happening here is s is a string object. Its data is the text hi.
Yeah.
And but it also has methods like dot length, has dot length, which tells you how many
word?
characters are inside, and or to upperCase, which transforms it to upperCase. The idea here is an object isn't just storage. It also knows how to work with its own data. A common mistake is thinking objects are just fancy variables or just files. They are more than that. So they're like living pieces in your code with both data and behavior tied together. Uh, so if we had a string word, for example, uh, string word is equal to uh, uh, equals to hello. What would word dot length give? It's gonna give 5. Uh, so that's about objects, data, and behavior. Let's move to variables and assignments. So a variable is basically a box in memory, yeah, with a label on it. So you can put uh, something inside that box, update it later, but pull it out when you need it. Um, in Java, we declare a variable by giving it a type and a name, like int x is equal to 5, x is equal to x plus 2, and here we first declare x an integer, then assign value 5, and later we update it, take whatever's in x, add 2, and put it back. Now it's gonna x holds 7. So a couple of things to watch out here is we don't try to use a variable before you assign it, uh, assign something. So Java will throw an error at you. And be careful mixing types. You can't just throw a decimal into an int without thinking about it. So another quick check is if if I write int x is equal to 3 and uh, x is multiplied with 2 plus 1, so what's the value of x at the end? uh, it's 7. It's basic math, but so objects are about data data plus behavior bundled together. Variables are your way of keeping track of information as it changes. Both ideas show up constantly in Java, whether you're uh, so yeah, if you do the Zybook activities, you'll get a better understanding, more understanding. But that's about basic variables. And next we have uh, we'll focus on the two practical things here: integer variables and identifiers. So these are the little details that will trip you up if you don't get them straightly straight at early. So let's keep it simple and clear. You'll we'll start with integers. As you know, in Java, the type int is for whole numbers. That mean no decimals. Values like -3, 0, 42, or 10,000. They're stored in a fixed range, so they go from about uh, -2 billion up to +2 billion. For our class, you probably won't hit the limit, but it's good to know it exists. Um, Now here the catch that gets almost everyone at some point is integer division. So if you divide one into another by another int, Java doesn't give you a decimal. It chops it down to a whole number. For example, system dot out dot println 5 divided by 2. So that prints 2, not 2.5. Why? Because both numbers are integers. We need not initialize it, but yeah, both numbers are integers. If you actually want a decimal result, at least one side has to be double. Uh, like for example, let's say 1 0. This is a double. Uh, that one prints 2.5. So that's uh, there's also uh, modulus operator, which is just the percentage sign. It gives you the remainder after division. So 7 modulus 3 is 1, because 7 divided by 3 leaves a remainder of 1. Super handy when you're checking things like even or odd numbers. Um, so for example, 7 modulus 2, it prints 1, so 7 is odd. A checkpoint, that one thing to remember is, what is 7 divided by 3 print? So that would be 2, because it throws away the decimal part. That's integer division, and that's that's what integer division is. So now let's move to identifiers. The names you give your variables. Identifiers are how you label uh, those blocks of memory so you can find them later. So Java has rules. Names can include letters, digits, underscores, but they can't start with a digit, and they can't be reserved keywords like class or int. There's also a style convention you'll see everywhere. Uh, that's camelCase. That just means that first word is lowercase. So each new word starts with the capital letter. So uh, something like total cost or like player health in game development. Uh, it makes your code way easier to read. So yeah, compare that to a variable named t. Sure, it compiles, but a month from now you'll have no clue what t means. So names matter. They tell you and your teammates here, if you're working on a group project, the story of what the code is doing. uh, so another thing to remember is second value a legal variable name? So no, because it starts with a digit. Like for example, this one, second value, uh, it starts with a digit. If you really want something like that, you should call it something like second, the word second, uh, like this, second value. But yeah, so to wrap it up, this topic, ints are for whole numbers. Watch out for integer division because it cuts off decimals. Use modulus for reminders. Always give your variables meaningful names that follow camelCase. Uh, these basics seem small, but they'll save you hours of debugging later on. So again, if you do the Zarbook activities on this topic, you'll get a more understanding. Uh, so next is arithmetic expressions. So we're gonna make sure arithmetic in Java does exactly what you think it does. Two parts. First, the general rules. Uh, General rules are uh, order of operations and parentheses. Then we'll narrow it to integer math. Things like counters, totals, and modulus operator again. Uh, so first is general rules. So when Java sees an expression, it follows uh, precedence, order of operations, and um associativity, which is uh, which is basically left to right or right to left for ties. The takeaway here is Java behaves like math class, like multi this multiplication, division happens before addition, subtraction, unless you use parentheses to say otherwise. Let me show you a classic example. So system dot dot ln 2 plus 3 multiplied by 4. So this prints 14 because it multiplies first 12 plus then addition 14. Uh, Another, like, let's put some brackets in here. So this prints 20 because addition 5 multiplied by 4, 20. So why in the first line, in the like in the this one, the multiplication happens first. 4 threes, yeah, 4 threes 12, then plus 2, that's 14. And as soon as we put some parenthesis, uh, the parenthesis force the add first. uh, so 2 plus 3 is 5, and then 4 times 20. So yeah, that's a classic simple example. um, Always remember, assuming everything runs strictly left to right. Um, it doesn't. If you want left to right, say it with parentheses. In real projects, parentheses are your friend because they make intent obvious to both the computer and the next human reading your code. Another thing to remember is mixing int and double without noticing the type. Like if you write 5 divided by 2, the integer division result is 2. So if you write 5 divided by 2.0, the double division, which is the result, is 2.5. uh, the type of the type of operands changes the result. So if you're doing anything that needs decimals, uh, like health range per second or smooth movement, make sure it at least one value is double or a float. And if the expression is a plus b divided by c, you want the addition first. How do you rewrite it? uh, Parentheses. So yeah, parentheses are the signal. If you want, something to be done first before. uh, Next is uh, integer math. So uh, the stuff you'll see all the times for counters, totals, simple checks. Few rules and patterns to remember is, first one is counters and totals. So counters go up or down by count, like count is equal to count plus 1 or count plus plus. Those are the counters.
What does mean count plus plus?
Basic addition. It's basically count is equal to count plus 1 every time.
Count is variable or?
Yeah, count is variable. Yeah, yeah. Everything we discuss, assume that it's a variable. If it's a name, uh, and
That means plus 2 plus means increase to number. Or
no, no, no. That's just it's let's go back. So here, usually we can write something like this: count plus 1. Uh, it's typical addition, but if you want to make it simple, you could just write count plus plus. This is just
plus 1.
yeah, plus 1. And total totals is basically, for example, total is equal to total plus something value. uh, this is a typical thing to write in a code. You could also, for totals is basically total plus is equal to value. Yeah, it's the same thing, but yeah, it's you'll why we are using this. You'll get a better understanding when you move to other chapters, when you're using for loops, if loops. These will be very very useful. uh, right now you might think we can write this instead of this, but you'll get a better understanding as we move forward. uh, Actually, let's do one example with this. Like, let's sum numbers from 1 to n. uh, this is very common pattern. Int n is equal to 5, let's say, and int sum is equal to 0. uh, and let's write for loop. Int I 1 I sum plus is equal to I, and let's print it. System dot println sum. So if you don't understand the for loop, it's okay.
But
But
we have to declare the I variable first or not?
we are declaring here int I is equal to 1.
Okay.
We could do it here, but I just did it here. It's the same thing. Uh, uh, so
I
here
understand it.
it's gonna print 15. So what's happening here is n is n is
And
5,
5, yeah.
sum is equal to 0, I is equal to 1. So it checks here I this is equal to, yeah, it checks with this, increments it, and it goes on until it reaches 15, like n times. uh, so that's a simple example. You don't have to worry about this
I
for loop
understand,
right
I
now.
understand. And
But
for loop.
so of and what else, like if you write something like this, you'd stop at 4 uh, and miss the 5 uh, when your total looks a little low, or your loop runs one extra time. So yeah, checks you can check the difference by running this code. And again, reminder, modulus. uh, so modulus gives you what's left over after division. It's great for even or odd, even and odd checks, cycling patterns, and every n frames logic. uh, for like, let's take the even or odd example. Let's change these variables. Num, let's give it 7. If num percentile 2 equals 0, system dot and println, it says even, and close this, else system dot out dot println odd. uh, yeah, this code basically checks if 7 is even or odd, uh, using the modulus and with 2. So yeah. What else? Another example is let's take tick 17. If tick percentile 5 is equal to 0, uh, do this special thing. uh, it's just an example. You could, it depends on your what your intent, what you want to do. It could be like cycling patterns, or every n frames, those kind of logic you'll be using modulus. uh, yeah. But this is a simple example. uh, so another thing to remember is you might forget what modulus returns. So it's not the coefficient, it's the reminder. So 17% modulus 5 is 2, because 17 is 15 plus 2, uh, leftover is
2.
2. So and we have integer only math. So with math, with int, Java discards decimals. So that can be exactly what you want, like counting enemies or bullets in a game, in game development. So but it can affect if you expect a precise fraction. So if you need decimals, switch to double or float, or make one side of your division a double. Uh, that's, uh, so let's look at another small example for. So hint h is equal to 7, uh, comma shots is equal to 3. Double accuracy is equal to h double shots. This gives 7 divided by 3, which is 2.333. So not 2. So yeah, that's an example. Um, how to test if n is a multiple of 5? You basically do n modulus 5 is equal to 0. If the remainder is 0, it divides evenly. That's a small example. But yeah, we'll discuss the next topics, the rest of the topics from chapter 5 in the next session.